Gautam.
Yes. So I hope you had the subject of metal science in second year. Somadip, you had metal science in second year.
Huh?
Am I correct? Second year metal science you studied in second year.
Second
Theoretical.
year. Second year first sem.
Second year first semester. Okay. Who was the teacher?
BO sir.
Okay. All right. So what is the importance? What is the why it is so important to know about the materials? Tell me first. Who can tell something? It's an informal discussion kind of thing, no? So you be interactive. Is it important at all, or you can go and do your work and come back? Is it important to know about the materials and why it is important? Who can say something on it?
So because different kind of materials
Yeah,
are used in the for engineering different things and products, like whole
right.
range of manufacturing.
Yeah. Metal selection is a very important process because suppose you have to manufacture a product, just like the design. In the very design stage, you have to think of what is the proper material you should choose, like which you can properly machine, which will be more reliable, which will be more durable, which will have less defects, so which will have maybe less weight. Okay, so many issues will be there. High corrosion resistant material, high wear resistant material. So material issue will be there in almost all phases of engineering. Now, my question, next question to you people, like, what do you mean? What is the difference between, like, what do you mean by metal science and metals engineering? What is
So
metal
material.
science and what is metal engineering? So Deepan is saying something. Anybody else, please? You should come forward because you have to face the interview on campus and off campus. So if you are shy, then how you will meet the strangers? Anybody, anyone other than Deepan Chakraborty? Please come forward and say something.
Sir, material science is the actual theoretical knowledge of the various types of materials and their properties and those things, and materials engineering is the application of that particular information in selecting various uh, or applying that knowledge to select materials for different engineering purposes.
Yeah, that is very correct, almost correct. Though you have to know theoretical about metals engineering as well, because without the knowledge of metals engineering, then how you can go for its practical application, right? So your guess is almost correct. Like metal science is basically a science which deals with the relationship between structure and the metal structure and the properties. Okay, you have to know how the different structures are there in metals available and what are the linked properties with it. Structure and proper relationship can come under what is called metal science. And once you are knowledgeable about that, then you can go for metals engineering. Very concrete example is in the third year, have you started the machine shop? Have you started the machine shop?
No, we haven't
Not yet.
started machine.
But machine shop is there, na, Somadip, in third
Yeah,
year?
yeah. In this week we will start.
Okay, I'm just understand. So, first job will be you will see probably making a pin. Okay, pin is not kind of small little pin you are using. So, kind of small solid round bar will be given to you, and out of that you have to uh, make a desired shape as per the instruction given, and which will involve different machining operations as per the instructions. Am I audible to you people, Somadip?
Yes, sir.
Now, why I'm referring to this case especially, so that machining is what is called conventional machining. It is not unconventional machining. The conventional machining, in the sense, there the requirement is that the cutting tool should be harder than the job material, because cutting tool, while you start machining, cutting tool will indent into the job, right? It will give some depth of cut, right? And you have to go for some feed, some cutting speed, etc. These terms are there probably in your machine technology subject. Now, the requirement is that the tool material should be harder than the job material. Otherwise, you cannot machine your object. Now, keeping that fact in mind, suppose you place your cutting tool on the tool post. So, do you know this term, lathe?
Yes, sir.
Yeah. So
Yes, sir.
yeah. So you know the headstock, tailstock, and the tool post, etc. So on the tool post, when you are setting that cutting tool to before start of the actual machining process. So as you know that our requirement is that the tool material should be harder than the job material. Fine. Now when you are placing this job over the tool post, as if it is projecting out of the tool post like a cantilever. Do you accept this? Because it is fixed at one end, no, and it is coming other portion is projected. This kind of cantilever, as we did study in
Yes,
your
yes.
strength material. And when you start cutting, start machining, some machining force will be there. Cutting force is the maximum highest force. So many forces are there. Feed force will be there. Thrust force will be there. But the cutting force out of this, the cutting force is the maximum. So when cutting force is going on the tip of the cutting tool, as if you are handling a cantilever with a point load at its free end. Can you imagine like this, Dipro? You
Yes,
have
sir.
you have you have you have fitted a cutting tool over the tool post.
Hmm.
You start machining, right?
Hmm.
Holding the job in between two centers, and after
Yes.
proper positioning of the tool and the job, you start machining. Now, when you start machining, some forces will be there. Out of the different forces, cutting force is maximum. So cutting force is coming on at the tip of the tool, and the tool is fixed at the other end. So it is like a cantilever subjected to a point load at the free end,
So
right?
cutting force is maximum. This part I didn't know. Like, is there any explanation of this thing? Like,
When
why
you
is it?
when this should have covered in your machine technology class. Have you started machine technology class? Machining technology class. Have you started
It has begun, but we haven't covered like this portion as yet.
machine technology in third year? I think no.
Yes, it's
So
combined as metrology and machining
yeah,
technology.
machining
That.
and metrology. So in machining,
Hmm.
in the conventional machining, which is the most common, is your turning operation. For example, you take the turning operation. So there, one force will is the feed force. Okay, one is the thrust force. Another is the cutting force. Okay, cutting force is uh, suppose when you go for machining any job, you need to supply some power requirement is there, right? So how will calculate the power? If you know the cutting force in Newton, you know the cutting speed V in meter per second, Newton meter per second, joule per second will be the watt required for the power required for machining. In machining, conventional machining processes, so many forces arises in the X, Y, and Z direction. Okay, as far as I remember, should be in the perpendicular direction, is it tangential to the job as you cut the job, and it should come on the in the normal direction on the tip of the cutting tool. So cutting force, feed is the the feed motion. So
Hmm.
feed force will be there, thrust force on the tool will be there, and the cutting force will be there tangential to the say the cutting circle. So out of these three forces, cutting force is the maximum. That is my I was telling like this. Cutting force, feed force,
Okay.
thrust force. These are the three common forces arising out of the machining process. So supposing the cutting force is acting on the tool, whatever the tool, even if the combined forces you consider, so you can well guess that some forces will be coming on the tip of the tool. So what may happen if you make the tool very hard? So what will happen? It can have crack immediately, isn't it? So what you have to do, you have kept your requirement in mind that the tool material should be harder than the job material. But along with this, you have to make sure that you have induced some toughness into it at the cost of brittleness, because more hard means more brittle. So slight force can give rise to what is called crack in the cutting tool. So what you have to do, you have to ensure some toughness into it by adopting proper heat treatment process. And proper heat treatment process you can design only when you have got some idea about what different structure will develop adopting different heat treatment process. Heat treatment process is very important. You will see that comes under what is called materials engineering. Heat treatment in general can be thought of as a combination of heating and cooling process. You have to heat a specimen above certain range, considering is a iron carbon alloy. Mostly we come across with this type of alloy as a mechanical engineers. So you need to heat your specimen above certain range depending on what is the composition, what is the percentage of carbon in the specimen, and then you have to cool it. Cooling medium also will be different. You can cool it in the furnace in its off mode. You can cool it in the air medium. You can cool it in the oil medium. You can cool even in the water quenching. Certainly will quench. Okay, sudden cooling. So that depends on the requirement. If the requirement is that you need very hard surface, then we usually go for the quenching operation. Now, question is, suppose you have made the specimen very hard, but as you could guess that if you make it very hard, because of the forces coming at the tool of the tip of the cutting tool, it can crack immediately. So you have to sacrifice some hardness, okay, and you have to induce some toughness into it by adopting another heat treatment over the heat treated one. So that is what is called tempering process. So this terminology will come across. You will probably better understand when you come across this particular topic in your uh, theoretical subject of machine technology and metrology. Sorry. I think it was there in the second year itself, machine material science. Heat treatment, DIPRO. Heat
Yeah,
treatment
yes, sir.
was there.
Yes, sir. Heat
Mm-hmm.
treatment was there. We
Yeah,
studied heat treatment.
yeah. So I think you know the tempering process. You know the tempering. You know the hardening process.
Yes.
Which will come first? Tempering or hardening?
Tempering should come first, hardening should follow.
Tempering should come first. And what about others' opinion? Do you agree that the tempering should come first and then hardening will come? This is third year mechanical Jadavpur University students. So do you agree with Dipro? Yes or no? So don't you think that these are important in the interview? Suppose you get interview in the Tata Steel, in the Tata Motors. Okay, so if you cannot answer properly the heat treatment section, any automobile industry will reject your chance. Will be rejected, right? So you should get ready on the heat treatment topic very well. So I'm
Okay, so
really surprised
tempering
to know tempering
it
always
comes
follows
after
hardening.
hardening. Yes, it comes after
Tempering follows
hardening.
hardening,
Yeah,
not
yeah.
the reverse. Okay, but your friends were
Exactly.
just silent. No answer from your friends. This is not that's why I was telling in the class. No, what happened with the Jalpur University student? You guys are very serious. Still joined in this exam. After that, you let it so loose. You will be bit by. You will absolutely be defeated by the students coming out of the private engineering colleges. So please take proper precaution on the very third year. My humble suggestion to all of you. So this is an example of materials engineering that you can design your material as per your requirement. Here the material requirement is that our cutting tool should be hard, but also it should be tough. So keeping that requirement in mind when you can induce some property into it, so it's become a topic of materials engineering. But materials engineering, how you can think of materials engineering if you do not know the structure and the property relationship? Now if it comes about the structure, you heard the term about the ferrite, you have heard about the time cementite, you have heard about the time martensite. What is ferrite? I was asked this question at your age, I still remember. And sir appreciated my answer. You should punch immediately, no? If
Sir,
you
a compound of like
do not
Fe2O3.
say something from your mobile and you will say, so that will be not, so just if you do not know, then so that you can take proper precaution in time. Yeah, Deepan,
Sir,
please tell.
compound of Fe2O3 compositions are present in ferrite compounds usually.
Ferrite, ferrite, ferrite composite Fe2. What is that? No, I am
Fe2O3.
asking. I am asking what is ferrite, because the thing is that whenever you go to this metrology laboratory, you will see that after some preparation, some micro examination, some structure you will draw. But the structure, what structure you are drawing, the definition, if you do not know, there will be big trouble. I can help you fine, but if the people come for recruitment, they will not accept you, will be rejected. Okay, so that's why these are the metal science. This is a big problem. Metal science is in high demand, but metal science has got lot of questions. If you cannot answer to the point, you will be driven. And even if you cannot avoid, even the steel company, automobile company, heat treatment are very much there. And suppose you are in a position to define annealing process, but you do not know ferrite. So who can answer? Alpha iron. Have you heard of this alpha iron? Have you heard this term alpha iron, gamma iron, delta iron? This is called allotropy in iron, isn't it? So alpha iron plus very small percent of carbon. That you please check 0.05 or 0.005 probably 0.05 or 0.005% carbon will give you ferrite. Okay, gamma iron plus 2.1% carbon will give you gamma austenite. So martensite, suppose you derive martensite, you should be in a position to say martensite is a supersaturated solution of carbon in alpha iron. So if you just say Fe2O3, you get 0. That's a big problem in material science. Each and every word is important. Got my point. So my suggestion, you please take proper precaution. Here in the class you can manage, okay? 45 minutes, 1 hour class will be there maybe. But you have got enough time. So in the meantime, you please just fill up all these holes then in preparation. So metal science is the knowledge by which you should have the idea of the structure and the properties, but it is seen that you are not very sure about the most common structure which you come across of iron and carbon, and this is you can better remember if you study well the iron carbon equilibrium diagram. I think you should have you have covered that also. Iron carbon equilibrium diagram. You have covered this thing. So there is one term called eutectoid steel. What is eutectoid? Do you remember? Because this is the question you can expect in the interview, I can tell you. And the beauty is that if you know something, you can just like you can ask the senior Hussein. Hussein is there in final year. Okay, Hussein, that day called me. He called me, sir, your tips acted for me very nicely. He got a very good internship and expect to get the final job in probably in Airbus or so. I gave him some tips, how we should make it through the final interviews. You can ask him. He was the captain of the class. Everybody used to sit silent and he used to answer. Just like this happening, like Dipro is saying something and Dipon is saying something, and you guys are sitting silent. I have no problem, but you will be facing problem. You will feel shaky. You cannot meet any strangers. You will fumble, and your chance will be not there. You'll be losing the chance in the getting a good job. So there is an opportunity. You must interact, isn't it? So eutectoid, do not know. Eutectoid, hypereutectoid, this term, I do not know. You have finished second year that day only. And probably you wrote an online exam, am I correct?
Yes.
Shomodip? Huh?
Online exam.
Online exam. So this is the beauty of the online exam. Okay, so please take proper care. The beauty of online exam is that Javadapur mechanical third year students are unable to answer the ferrite martensite or eutectoid, etc. And your seniors got first rank in the GATE exam and all. So all of your good boys, please just change your course of action. Anyway, so coming to this today's topic, of few slides are there in front of you. Actually, the first job will be that you have to prepare a given sample. Prepare means preparing for the micro examination. So for preparation, what are the different steps? Each and every line I will not read for you. So you please read that line later on. You go to the next slide, please. Why microstructure analysis is important? Okay, so that's quite self-explanatory. Please study this thing: quality control, failure analysis. Right. So some part of a product are having a recurring crack. So it is quite possible that you need to check the metal quality and need to collect the sample from that affected area Okay, so that's called failure analysis. So failure analysis is not only for the application of force, but also the poor quality material may also be reason for the failure. So next slide, please. Application. Just see the fourth point. Just see the fourth point here. Design alloys with new properties. I have given you the example. Okay, so study and characterization of material. Characterization means in this micro examination. Okay, some characterization can be of different type. You can go for mechanical characterization. Suppose you want to study surface roughness, hardness. This is also mechanical characterization. Suppose you want to study the corrosion resistance, it becomes chemical characterization. So many characterizations for processes are there, so that you can go for that. Next slide. The steps are there. The safety precaution is quite obvious. That is strong acids you can come across. You should be careful about that. Next slide, please. Yeah, this is very important. Specimen preparation is so your first job will be the specimen preparation. The specimen will be given to you, and you need to prepare it for the metrology examination. Okay, it requires deformation-free specimen, flat specimen, no thermal damage, no scratches. You have to make sure that no distortion is there. Specimen remains flat because ultimately you have to take it under the microscope. Okay, no thermal damage. I don't think its chance is there at all. So not very big force you can apply there. No scratches means as far as possible you have to make the surface smooth, but mere smooth also may not be able to give you proper reflection in differentiating with the grains and the grain boundaries. You have to go for the chemical attack using the etchants. That is coming later on. Next point. Next. Yeah, this is very important. This is very important. See, sectioning, mounting, grinding, polishing, and etching. So sectioning means, suppose one product is there, your company has made a product, and that particular product in a particular zone, there is crack is developing. So what you can do, you have to think of how you can correct the sample from that affected area. So sectioning means that whether you can collect a small chips, or if it is a totally failed component, then you can take even the bigger piece, bigger sample. So sectioning means basically it talks about collecting of the specimen. Sectioning means you have to just collect it by cutting it with proper method. So you can, whether it is a big cutting process or the small grinding process, that depends on the shape of the specimen or the final product from which you are collecting your specimen. That's called sectioning. Sectioning means some collection of some sample by sectioning process, by cutting process from the affected area where the crack has developed. Mounting means sometimes it is quite possible that the collected sample is very small in size. So if it is very thin, awkward specimen, then probably you cannot go for its preparation well if you do not hold it in some other material. So mounting means basically for study of the thin, awkward sample. So you have to hold the specimen in some plastic material by some proper process. So mounting is basically holding the very thin, awkward specimen for the micro examination in some other process. So mounting, probably one experiment is there in the lab itself. So mounting is not required for each and every sample. If the sample size is very small, very thin, awkward specimen, then you have to go for the mounting by holding the job in some bakelite powder, heating, pressing, etc. Your thin job will be held in that particular plastic material. Now, whether you go for mounting or not, probably mounting will not be there in the first your experiment. One sample will be given to you, and also I do not think you'll be going for the grinding immediately. You have to go for using the emery papers. Emery papers you might have seen that is being used at your home sometimes for polishing the wood or even the metallic surface. So different sizes of emery papers will be there depending on the size of the abrasives. Okay, bigger the abrasive, the more coarse things will become up, and finer the abrasive means you are going for final polishing. Then you go for grinding for better finishing, better polishing. Then you go for polishing. Polishing means maybe some polishing wheels are there, mechanized wheels are there. Over that you can apply silicon carbide or aluminum oxide abrasives depending on what is the type of the job material, whether the job material is ductile material or the brittle material. Then so MRE paper, using MRE paper, then grinding, then polishing is a sequence roughly. And then after this mirror finish polishing, immediately you cannot take it under the microscope. You have to go for etching. So etching means you have to go for some acid attack. And what is the type of job material? Etching agents are also different. By etching, you are basically making the surface a bit rough so that uh, when the light rays are coming under the optical microscope, and when it is reflected back, so the grains and grain boundaries are well can be differentiated. So these are roughly the different processes that is there in preparing the specimen for the sample metrology examination. Next slide, please. So this has been elaborated actually. You see, sectioning. Sectioning is basically first step, as I have told you. Okay, you can go for abrasive cutting is the most common. Then cutting tool made of silicon carbide. Abrasive cutting means say cutting wheel, say grinding wheel by you can just you are using small chips will come out of the structure. Not that very big piece you can cut. What are the other method of sectioning? Next slide. Okay, sawing. So if it is a suppose it is a failed component, so you can go for using saw. Okay, so abrasive wheel section means wheels are very thin specimen is there. Abrasive wheel you must have heard about the grinding wheel. Okay, grinding wheel in some houses, if you might have seen that over the
Knife
boundary wall.
sharpening, those things
Yeah, yeah,
happen.
yeah. You might have seen that the boundary wall of some houses, some glass pieces are there projecting coming out. Have you seen glass pieces are there, sharp glass pieces, so that the trespassers cannot come out,
Yes, yes, yes.
cannot pass
Yes.
the wall easily. So that glass pieces you can think of the abrasives, and the material in which it is being fixed is called you can the bonding material. So grinding wheel, basically it's a thin grinding wheel. Abrasive wheel means so abrasive particles are being held in some grinding in the bonding material. Abrasive particle can be of different type: aluminum oxide, silicon carbide, etc. Diamonds also. That depends on what is the type of the job material. Depending on that, you have to select the particular wheel. Okay, and bonding material is basically for holding that abrasives. So this is all for sectioning, but sectioning will depend on what kind of failure component you are considering. If the product has already failed, broken component, so you don't mind taking a bigger piece. If the product is still operational, it will take a very small, thin specimen. Then you maybe have to go for some grinding wheel, and some chips will come out of that. And by proper mounting, you can go for metallography examination. Next, please. Sectioning. Yes. EDM also you can electric discharge machining. There's also different methods are there by which you can go for sectioning of the sample from the affected areas. Okay, but this part is absolutely absent in your case because it is already sectioned. Some sample is already there. You need not to go for any sectioning. But in general, you should know that mammography examination will not start suddenly. No, it depends on the requirement at the field. Suppose you are working in a automobile company and one car is developing crack in a particular place. You have to go there. You have to find out where is the problem. Okay, suppose you are working in a ONGC, Oil Natural Gas Commission, and the drilling operation is there for the taking of the oil out of the mines. So maybe the drills are having crack in a particular place. So you need to study that. You need to collect the sample. So what type of job, what type of product you are considering, based on that you have to select what type of machines will be required for the sectioning for collecting the sample. Next, mounting is there. Mounting, as I told you, mounting means if it is a very thin awkward specimen, then you have to go for mounting. Just like it is mentioned, they are mounted inside the polymer block. Okay, very small may not be suitable. Just you see, small sample can be difficult to hold safely during grinding or polishing, and their shape may not be suitable for observation on a flat surface. Already I have told you, if it is a very thin specimen, thin awkward specimen, just like if you see the right hand figure, the square shape one, the yellowish one is basically the sample. that you need polishing and the structure that we're looking for, and the round portion is basically the holding material. Okay, and usually it is the bakelite powder things. One experiment is there probably you will do in the lab. So mounting is required. Do remember only for a very thin awkward specimen. Next, it can be of different types of mounting are there. You please study yourself. Cold mounting, hot mounting. I think in our case it will be consisting of cylindrical rings, also the mold flat pieces. Is how the basis within when the mixture poured in and allowed to set. Takes, I think, go to the next one. I don't think it cold mounting will be there in your case. I think hot mounting will be there. Yeah, yeah. This thing you will to do. Maybe it will be experiment two here in your lab. Sample is surrounded by an organic polymer powder. As I told you, bakelite powder probably you will see. And the influence of heat and some pressure is applied by a piston. Okay, and allow some time to cool to get set and then take out the specimen, and that will look like the earlier slide that we were showing. So mounting, as I told you, for holding thin awkward specimen for proper metrology examination, and I think the hot mounting will be used in your case. Next, please. Okay, so here grinding, here you see there are a number of grades of paper. Here you are talking about the MRE paper actually. Grinding is done using rotating disc covered with silicon carbide paper. You will not, I do not think you will do it immediately. First, they will give you, the technician will give you some MRE papers. Some grades will be there. You please ask him what are the grades that is being used. You see here some numbers has been given here. If that may not match with what you are doing there, you please ask him. Suppose here is 180 grade means represent the coarsest particle. Okay, this is the grade to begin the grinding. As I told you, it is start with the coarser particle. Coarse means the abrasives are quite coarse in size. Okay, and always use the light pressure applied to the center of the sample and wash the sample and move to the next grade. Orient the scratch is very important. Okay, so you do not just go on polishing in one direction. So make it in a different direction so that it is distributed uniformly. And see the number increases. Here it is the number is the final paper is 1200 means uh, the abrasive particle size is very fine there. That will ensure a bit smoother surface. Then wash the sample and followed by alcohol and dry it before moving to the polishers. I do not remember. I do not think they will use alcohol. Just kindly check it there. Okay, next. Polishing. Here, polishing will be there. You will see aluminum particle Al2O3 alumina. Aluminum will be given in the form of slurry. Okay, some blackish slurry will be there, and you will see some switch. You will start probably. It will rotate, and you have to take the sample over it. So only thing that will give you the better polished specimen, better polishing only. So begin with coarse slurry and continue polishing until the grinding scratches have been removed. The vital importance that sample is thoroughly cleaned using soapy water followed by alcohol. So this is the slides have been collected from the net sources, so it may not exactly match with what you do there, but in general that should match your work. Polishing wheels are there for sure, uh, but I do not think they will be changing different slurry here. I think one slurry, only one type of slurry will be there. I don't think whatever changes are there, that changes in the whenever doing for the manual grinding, maybe the MRE paper grades will be changing. But probably slurry, uh, this thing will not change. That you please check. So polishing here means you are basically keeping your job in contact to the rotating disc. And over the rotating disc, the slurry of the aluminium particles are there. So this is basically acting as an abrasive for you and which will further clean the surface and polish the surface. Okay, then you go for etching. Yeah, etching. Shomadip, can you help me now? Please study this thing.
Yes.
Yeah, you please read these pages, these few lines. We will finish within 2-3 minutes time.
The purpose of etching is twofold. Grinding and polishing operations produce a highly deformed, thin layer on the surface which is removed chemically during etching. Attacks the surface with preference for those sites with the highest energy, leading to surface relief, which allows different crystal orientation, grain boundaries, precipitates, phase, and defects to be distinguished in reflected light microscopy.
Now, see here, you are not going for any energy calculation, nothing, right? But you can well guess that if it is a completely super fine after polishing, if you take it under the microscope, what will happen? Your incident ray and reflected ray will come on the collinear. If it is slightly, if we attack the surface with preferences, means when immediately after the polishing, if you etch it, what will happen? Your incident ray and reflected ray will make some angles. Final structure, what you see under the microscope, you will be able to differentiate between the grains and the grain boundaries. That is the thing that is being mentioned here. So etching will ensure that you can have the incident ray and the reflected ray having some angles. Okay, the different zones will be totally clear. Other than energy calculation, highest energy, lowest energy, that you are not doing here, absolutely. But purpose only I'm telling about. And what are the different etchants that is mentioned, I think, in the next slide. Industrial etching is also there.
Etching
Industrial
should
etching means
always
for
be
the big one.
Etching should always be done in stages, beginning with light attack and examination in microscope, and further etching only if required. If you over-etch a sample on the first step, then the polishing procedure will have to be repeated. The table below gives the etchants for alloys that will be examined in this
I
experiment.
think for you the last one, steel and this thing, I think you will be
Steel
using
and
nitrile
custom.
here. Okay, so make sure when you are using this thing, you take proper precautions. So these are some of the things that you are likely to do in the first job. Collecting part is not there. Sectioning means if you go for collecting of the specimen, collection is not there. Sample is ready for you. If you go for the grinding means you are using a MRE paper. Then go for polishing. Polishing means holding the job against the rotating wheel, having abrasive slurry on it, AL203. Then go for etching, and then check out the microscope. But the problem is, supposing what is the material, right? If it is a ferrite structure, if you see the ferrite structure, then when you see the different phases, okay, just see what in the instruction sheet what they have mentioned, what is the type of material being given to you. So that structure you should be able to define the structure. What is ferrite? What is martensite? So please do this thing very well, because hardly it will take for you maybe 1 hour 45 minutes time. But so many theoretical things you should prepare yourself. So with this I will wind up for today. Shomadip, any question if you have, please. Anyone?
This paper, this page.
They
Just
are showing
finishing.
the how the grand
Oh,
ground borders. Any question from your side? But my request to you that job you can do very in time, but metal science will invite lot of theoretical questions. My suggestion that you please take proper preparation, just like you used to note. I hope you have noted few keywords that I mentioned. You have do you have any metal science book with you? Any book you have purchased? Probably no, because it is an online class. No one probably. This is the thing. So that's the big problem. Will metal science engineering, William Smith, D. Callister, because I used to teach this subject last 25 years. How many good students we have prepared, we have seen. All of you are good students, I'm sure, but do not let it so loose. Others will escape and they will grab the bigger jobs. So thank you so much. So tomorrow we are meeting. Tomorrow you please go there. I told Shomadip. Shomadip,
uh, Second floor.
Somadip, I am passing to you the Mr. Ganesh is there.
Okay,
He
okay.
is the supervisor. So you please assemble there in time. Okay. So you talk with that sir. Maybe I will go there in between only to see once and come back.
Yes, sir. And
Whatever is to
second
do, I
second
think.
floor blue art. Blue art second floor. Right.
Yeah, Blue Earth absolutely go inside of the Blue Earth, right? Then take left turn, okay,
Hmm.
and then go first floor. There's no
Hmm.
second floor. First floor, right hand side, Metrography lab.
Okay.
Okay, and Mr. Ganesh's number also I'm sending to you.
Okay, sir.
He is the man supervisor. Okay, but I expect and I request that make the class interesting. I need to know something from your side as well. Not that we know everything. Our students are also quite genius.